Hi. This is going to be a little bit of a different thing. I'm not actively taking notes, so you're just going to be watching basically a bunch of different pictures I took because I didn't want to. You'll see why in a minute. This lesson is on what are rational numbers, and you can actually see it right here on the side. What are rational numbers? That's the name of the video tonight. So this is what rational numbers are. Rational numbers are numbers that you can turn into fractions, which might sound kind of complicated, but really you've been working with numbers that you can turn into fractions for quite a while. So we're going to start with the most basic ones and work our way up to what we're going to be doing a lot in class for this second unit. So first thing is this. We have natural numbers. I didn't put any numbers in this one, but natural numbers are numbers 1, 2, 3, and so on. They're whole numbers, but they're not whole numbers. That's actually a different thing. So natural numbers are my first circle, and you might want to watch this video through before you start drawing this, just as a heads up. After natural numbers are whole numbers. So I actually have, if you see, natural numbers are 1, 2, 3, and they go on forever. I'm actually going to open up one of my fancy applications here. And that's what it is. Come on, there we go. So natural numbers 1, 2, 3, 100. I skipped a few. 1,000,000. So long as it's not a fraction. All right, now here we go. Now I've got here. If you notice, the only extra part of whole numbers is actually that 0. 0 is the only extra number in the natural numbers. Like 1, 2, 3, and 100, like those are natural numbers, and they are whole numbers also. 0 is not a whole number. I do not have 0 right here. So it's not a whole number, a natural number, but it is a whole number only. Okay, so that's our second thing. Well, and then now we're on whole numbers and natural numbers. These are all inside of what we like to call integers, right? We have -4, -3, -500, and if you notice right here, I know it's kind of hard, this one was hardest to read, this one was the red. 1, 2, and 3 are also integers. So not only now do we have positives, now we have negatives. So those are integers. So integers include natural numbers, which include whole numbers. So we've got all these different things going on at the same time. Sorry, as integers include whole numbers, which also include natural numbers. So that's what's going on with those. So go and keep drawing, and I'm going to keep going, and this video is pretty short actually. My next thing, integers are inside of, and this is the whole point of the main lesson, are rational numbers. And I did write it up here. Oh, you can't see what I'm pointing at. Right up here, if you'll take a gander. Right here is where I've put the definition of what is a rational number. A rational number is a number that can be turned into a fraction. If you have Mr. Lynch for math next year, he asked you this question the first day of class. In every class he's had, Algebra 1, for the past 2-3 years that I've been working, every year. What is a rational number? He'll ask every student that walks through the door. And here are rational numbers. 4/3 already is a fraction. -3 and 1/half, that's already a fraction also. It's right here. 145, it's a whole number. It's also a natural number. And remember, I can turn this into a fraction by putting a 1 underneath it. Any whole number, I can always just put a 1 right there, and then it becomes a fraction. 3.45 can turn into a fraction. We're actually doing that in the next couple of days. We're going to be turning fractions into whole number, or sorry, decimals into fractions. This thing right here, this one looks a little weird. This is 0.3 repeating. That's what that line means right there. That means it goes on forever, and it keeps repeating and repeating. If a decimal goes on forever, that doesn't make it a rational number. It has to repeat. When it starts to repeat, that's what makes it a rational number. It has to be able to repeat. If it doesn't repeat, it is not irrational. Okay? Oh, sorry about that. Okay. And I'm gonna go even a step further. Well, what's the opposite of a rational number? Well, the opposite of a rational number is called an irrational number. And those are numbers that cannot, look at that, cannot be turned into a fraction at all. Ever. Period. Cannot be turned into a fraction. Such numbers as pi, you all know that, well, that's equal to 3.14 yada yada yada. Like, it goes on forever and ever and ever. It doesn't ever repeat. It'll never repeat. So it is pi. It is not an irrational number ever. I put it right here. This might be something new to you. This is called a square root symbol, and this is more in chapter. This is more in the 4th chapter of the book. This is something we're going to cover more in detail in the 2nd quarter. So this is more in my 4th unit, and we don't do the 4th unit until the 2nd quarter. So we'll talk more about irrationals later. Our main thing that we want to focus on are the rational numbers. So, a lot of writing tonight. I know you got to do a lot of coloring and this and that. I just went through this because I had to take a picture every time so you could have it. So, have fun doing this video, and that's basically it for notes. We're going to be doing an activity with some stickers. I'm pretty excited about it. So, I'll see you when we do chapter 2.